Welcome to this presentation on Spectroscopy Basics. In this lesson, we will learn how light interacts with matter and how scientists use this information to identify, analyze and understand different substances. I hope you will enjoy this session. Now, what is spectroscopy? Spectroscopy is a scientific technique that studies how matter interacts with electromagnetic radiation. When light falls on a sample, it can be absorbed, transmitted, or emitted, and each of these responses gives us valuable information. Using spectroscopy, we can determine the structure, composition, and chemical properties of the material. Spectroscopy plays a vital role in modern science. It helps to identify chemical compounds, measure concentration with high accuracy, determine molecular structure, and detects impurity in sample. This makes spectroscopy essential in pharmaceuticals, industries, research and environmental analysis. Spectroscopy uses different regions of electromagnetic spectrum from high energy gamma rays to low energy radio waves. Gamma rays have high energy. However, energy decreases from gamma rays to radio waves, and radio waves have less energy and longer wavelength. Each region provides specific information about molecules. For example, UV and visible light show electronic transitions. IR light shows vibrations and microwave shows rotations. Now we will discuss the different types of spectroscopy. There are several types of spectroscopy. And UV visible spectroscopy studies electronic transitions. Infrared spectroscopy identifies functional groups through vibrations. Nuclear magnetic resonance spectroscopy reveals molecular structure using magnetic field. Mass spectrometry as shows the mass to charge ratio. Fluorescence spectroscopy examines different lights emitted from the sample, and X-ray spectroscopy provides atomic level information. UV visible spectroscopy measures how molecules absorb UV visible light. This absorption causes electron to move from lower to higher energy level, and the common transitions include pi to pi star and n to pi star transitions. It also helps to determine the concentrations by using Beer-Lambert law. Now we will discuss the infrared spectroscopy, and it identifies molecules based on their vibrational patterns. Different bonds absorb IR radiation at different frequencies. For example, OH bond, C double bond O, NH bond, CH bond show characteristic peaks. This makes IR spectroscopy very useful for identifying functional groups in organic molecules. Nuclear magnetic resonance spectroscopy, it studies the magnetic properties of the nuclei. When nuclei like hydrogen or carbon-13 are placed in a magnetic field, they absorb specific radio frequencies. The pattern produced help determine the exact arrangement of atoms in a molecule. NMR is one of the most powerful tools for structural analysis. Beer-Lambert law. The Beer-Lambert law describes how absorbance is related to concentration, where A equals to epsilon multiplied by concentration multiplied by path length. If we know the absorbance and molar absorptivity, we can easily calculate the concentration of an unknown sample. Now we will discuss the basics of sample preparation. Accurate results in spectroscopy depends upon the correct sample preparation. So choose an appropriate solvent, prepare solutions with precise concentrations, and always use clean cuvettes. Avoid air bubbles and fingerprints on the cuvette surface. Always calibrate instruments before starting measurements. Spectroscopy has countless applications in science and industry. It is used in pharmaceutical quality control, environmental monitoring of water and air, food and cosmetic analysis, nanoparticle characterization, medical diagnosis, and forensic investigations. Its versatility makes it one of the most widely used analytical tools. To summarize, spectroscopy is a powerful analytical technique that helps us understand materials by studying their interaction with light. Different types of spectroscopy provide different types of information. Mastering these basics is essential for advanced studies in chemistry, biology, environmental science, and materials research. Thank you for watching this presentation. If you have any questions, feel free to ask. Please like, share, and subscribe for more educational videos on chemistry and analytical techniques.